This section of your flipbook deals with calculating the area of a triangle. This again should be review for all of you. You should have seen the area calculation for a triangle in previous math classes. But I'm going to go ahead and review the basic properties of triangles and the area formula, and then we'll go into some of the types of questions you're going to see in this unit. This is found in your Intro to IM2 flipbook, section number 5. It is the bottom flap of section number 5. If you go ahead and fill in the title of this section, which is area of a triangle. And I'm going to go ahead and do the fill in the blank first, and then we'll talk about properties of triangles and the area formula, and then we'll get to the problems. So, first thing is, a triangle is a three-sided polygon. Talked about the definitions of polygons. Any polygon with three sides is a triangle. You can make a triangle by dividing a rectangle in half with a diagonal. Now, this is important to recognize. Take any rectangle. In fact, any quadrilateral, could be parallelogram, rectangle, square, rhombus, and if you divide it in half by drawing a diagonal line between opposite corners or opposite vertices, you'll divide that shape into two triangles. And the reason I'm covering this is because this helps us to remember where we get the area formula of a triangle. So let's take a look at some of our examples here below, some triangle shapes. If you want to go ahead and write down here in the corner right now, the area of a triangle is equal to 1/2 of base times height. Remember that the area of a rectangle is area equals base times height. We get this 1/2 exactly because of what I just explained. Because a triangle is really just simply half of a rectangle. That means the area is going to be half of the base times height, or half of the area of the rectangle that it's part of. Take a look at some examples here of triangles. Let's label this one as a right triangle. So this is the most common triangle we're going to deal with in this class, a right triangle. And this is pretty easy. We've got a side of this triangle that's horizontal, so I will call it the base because that makes the most sense. And then remember, the height of any polygon is measured from the base straight up to the very top of the object or shape, and it's got to be perpendicular line, and that is going to be the height. So what's nice is for a right triangle, it's just one leg or one side multiplied by the other leg or the other side. Recognize here, class, the hypotenuse has nothing to do with the area of a right triangle. Now here's another triangle, and just because it's not a right triangle doesn't really make it a whole lot more complicated. In this case, we have our base. I'm going to go ahead and just label the bottom horizontal side as a base. And remember, just like our rectangle, we're going to have a line measured or segment measured straight up from our base at a right angle, just like you would measure your own height. And the distance between this point touching the base and the top vertex, or the very top of the triangle, that is going to be our height. So this triangle, even though it's not a right triangle, we still use the 1/2 times base times height. Now, one of the ways this can get confusing is if I rotate this whole triangle around a little bit, sometimes you'll lose track of what the base is. I'd recommend just turn your paper so that you're looking at one of the sides and it's exactly horizontal from left to right. Label that your base and then figure out how you're going to use the properties you learned in math to figure out what the height is. This last one is an obtuse triangle because we have a measure in the triangle that's greater than 90 degrees. Now this one looks a little bit different, but we're going to measure it almost the same. Here is our base, and I'm gonna highlight it so you guys can see this. This is our base. Our base is the actual measurement of this horizontal side of our triangle. Let's go ahead and label that as the base. Okay? And then the only reason this dashed line is here is to show you, to measure the height of this triangle, we can just temporarily extend the base out. We're going to create a right angle or a perpendicular line right here. And this measurement right here is then going to end up being our height. Now notice the height is not one of the sides of the triangle like a right triangle. It's just like the height of this acute triangle, only we can't, if we measure straight up and down from the base, the problem is you end up with a point over here. And how do you know when you've reached the very top? So by extending the base out temporarily here and then drawing a perpendicular line, now we have a line that can tell us what the height is. Now be careful, because when you measure the base, don't include this dashed line. The base is actually the horizontal or bottom edge of this particular, or bottom side of this particular triangle. Okay, so there's some examples of how to figure out the base and the height on various shaped triangles where you can use the formula area equals 1/2 of base times height. Let's go ahead and do some examples now. First example is, what is the area of a triangle with vertices at A, B, and C? And you're going to need to go ahead and plot those on your graph. And while you're plotting those, I'm going to go ahead and connect those vertices together so we create a triangle. Again, class, I keep telling you this. Please do not hand sketch these. Use a straight edge. If you don't have a ruler, which you should have, if you don't have a ruler, use your student ID or some other straight edge surface to draw those straight lines. Okay, so we've plotted the points. Let's see if we can identify what the base is and what the height is. It's actually pretty simple. The base, we've got a nice horizontal line right here. I'm going to use that as the base. And this base is 1, 2, 3, 4, 5. The base is 5 units. We can just count because this is an exact horizontal line. And let's go ahead and draw a dashed line. C is our top of our triangle at this point. I'm going to draw a dashed line straight down that is perpendicular to the base. I'll make that a little bit clearer here. Perpendicular to the base, or it makes a 90-degree angle. And so I can now figure out what the height is. Starting from this point, 1, 2, 3, 4. So the height is 4. And I'm just going to draw an arrow here so you guys can see height equals 4. So we've got a base of 5 and a height of 4. That's going to make our area pretty simple. The area of this triangle is going to be 1/2 times the base times the height, which is 1/2 times the base value, which is 5, times the height value, which is 4. Now you can plug that whole thing into their calculator by putting in parenthesis 1 divided by 2, close parenthesis, then times 5 times 4, and you're going to end up with 10. And remember, area is going to be in units squared. We're not told. This is miles, feet, inches, millimeters. So the area of this triangle is 10 units squared. Biggest mistake you'll make on a test is you'll forget to multiply this by 1/2, and you'll say the area is 20 units squared. So be careful. Remember, area of a triangle is 1/2 of base times height. Okay, this one gets a little trickier. What is the area of a triangle with vertices at A, B, C? Here are our points, so go ahead and plot those. And while you're doing that, I'm going to go ahead and connect those. Remember, class, the good part about a video is you can pause at any time to catch up. What you don't want to do is just blindly copy things and not listen to what I'm teaching you, because I'm giving you a lot of helpful information by how I'm talking you through these problems. So pause if you need to catch up, and then listen to the dialogue along with the work. Okay, so there's our triangle, crazy looking triangle. Clearly it's not a right triangle. Was our last one a right triangle? No, it was not. It was acute. Okay, this is an obtuse triangle. So let's figure out what we're going to use as the base. I'll tell you right now, I'm going to use a horizontal line, horizontal segment. So there is my base. And I'm going to pick my base, which is equal to 1, 2, 3, 4. So the base is 4 units. Now remember, BC is not the height. Remember, we don't measure height by making a crooked line. It has to be straight up and down. And I'm going to go ahead and just go to point C, which I know is my highest point compared to my base. And I'm going to draw a dashed line straight down from there. And I'm going to extend my base out temporarily, make a dashed line right there. That just creates a right angle. This is my height from this point to this point. So my height here is 1, 2. So H, let's put an arrow again because I can't see it very clearly. Height is equal to 2 units. All right, and now we're down to the easy part. We figured out base and height. Area is equal to 1/2 times base times height, which is equal to 1/2 times base, which is 4, times height, which is 2. Put that in your calculator. It's going to be 1/2 of 8. 4 times 2 is 8, so 1/2 of 8 is 4. And this is area, so it's going to be unit squared. Let's change that to a little neater. Oh, I wrote the exact same 4. Let's try it one more time, otherwise I'm going to give up. There we go, 4 units squared. And there is the area of this obtuse triangle. Remember about the 1/2 in class? Please do yourself a favor. Always write the area equation before you start plugging stuff in. It's students who refuse to do that and just put 4 and 2 down here and do a messy job. Those are the students that normally miss the fact that we have to make sure we multiply this times 1/2.